Hey everyone, have you ever hit run on a piece of code and just wondered? Like, what actually happens in that split second? How does your computer take those words and symbols and turn them into something it can actually do? Well, today we're going to pull back the curtain on a really elegant way to solve that puzzle. So let's start with something super simple, right? I plus I. For us, that's instant. We see it, we get it. But for a computer, it's just a bunch of characters in a row. It has no inherent meaning. The big question is, how does it get from that meaningless string of text to an actual instruction? That's the mystery we're going to solve today. And here's our roadmap. First, we're going to meet the hero of this story, the parser. Then we'll check out its strategy, which is called the top-down method. After that, we get to the really cool part, how grammar rules can be perfectly mirrored in code. Then we'll see it all in action, and finally, we'll get to see what a successful parse looks like. All right, first up, let's get properly introduced to the piece of software that does all of this heavy lifting. So you can think of a parser as kind of like the grammar police for your code. It's this internal translator that reads everything you write and makes sure it's playing by the rules of the programming language. If everything checks out, it doesn't just give a thumbs up. It actually builds a logical structure out of your code. The specific kind we're looking at today uses what's called a top-down approach, which is awesome because it's built to be fast and efficient. So what's the game plan? How does this parser actually go about understanding our code? Well, it uses a very specific strategy. And that strategy is called top-down parsing. The best way to think about it is this. It starts with the biggest, most general idea, like, say, I'm looking for an expression. And then it tries to break that big idea down into smaller and smaller pieces, hoping to perfectly match the code you actually wrote. It's all about going from the big picture goal down to the nitty-gritty details. Now, for this whole thing to work without getting confused, the language's grammar, its rulebook, has to follow two very important rules. First, no left recursion. That's a tricky situation that could literally send the parser into an infinite loop, which is not good. And second, no non-determinism. That just means that at every single step, the parser has to know exactly what to do next. There can't be any ambiguity. Okay, this next part is the absolute core of this whole process. It's a genuinely beautiful idea, this incredible, almost magical connection between the abstract rules of grammar and the actual concrete functions in our code. This brings us to the Recursive Descent Parser. And honestly, the name kind of gives the whole secret away. It's built from a bunch of functions that can call each other, and, this is the key, they can even call themselves. That's the recursive part. Each one of these functions has one job, to recognize one piece of the grammar, one concept like an expression or a statement. And here it is. This is the magic trick. On the left, you've got a grammar rule. It just says an expression, which we're calling E, is made of an identifier, I, followed by another thing, E prime. Now look at the code on the right. It's a function named E. What does it do? First, it looks for an I, and then it calls another function named E prime. See that? The code is a direct mirror of the grammar. This is the whole idea right here. You can literally write your parser by translating each grammar rule, one by one, straight into a function. Okay, theory is one thing, but seeing it work is way more fun. So let's trace exactly how this system takes our simple little string, I plus I, and makes sense of it, step by step. So here's our setup. We have our input string, I plus I, and you'll see that $sign at the end. That's just a special marker that means end of the line. We also have something called a lookahead. Think of it like a cursor that points to the character we're currently looking at. Right now, it's on that first I. And of course, we have our simple grammar rules ready to go. And we're off. The whole process kicks off when the main function calls our starting procedure E. The first thing E does is look at the lookahead character. Does it see an I? Yes, it does. Perfect. So it matches it, basically eats it up, and moves the lookahead cursor to the next character, which is the plus sign. Then, just like its grammar rule says, it calls the next function in the chain, E prime. So now we're inside the E function. It checks the lookahead, it's a plus. Exactly what it was hoping for. So it matches the plus, moves the cursor. Then it matches the second I, moves the cursor again. The cursor is now sitting on that end of string $sign. And here comes the coolest part. The grammar rule says E now has to call itself. This is that recursive call we were talking about, checking to see if the pattern continues. So we dive into E a second time. It looks at the lookahead. But wait, this time it sees the $sign, not another plus sign. So the condition is false. This triggers the other option in its grammar rule, that little epsilon symbol, which basically just means match nothing. It's the parser's way of saying, okay, I guess we're done here. So the function does nothing and just returns. The recursion is over. And that single return starts a chain reaction. Control pops back up to the first eCall, which is now done. Then it pops back up to the eCall, which is also done. And finally, we're right back where we started, in our main function. And what's the most important thing? Our lookahead cursor has made it all the way to the end of the string. Okay, we've gone all the way down the rabbit hole and come all the way back up. It's time for the final verdict. Did we do it? Did it actually work? The main function performs one last, incredibly simple check. It just asks one question. Is our lookahead cursor pointing at that end of string marker? Is it pointing at the $sign? And the answer is yes, it is. We successfully processed every single character in our input in the right order according to our grammar rules. It's a successful parse. We did it. And what's the result of all that work? It's this structure called a parse tree. You know that whole sequence of function calls we just walked through? Well, by making those calls, the program implicitly built this exact tree. This is the structure, the meaning, that the parser was able to pull out of that simple, flat string of text. Pretty amazing, right? So if you take one thing away today, let it be this. Through this really elegant trick of mirroring grammar with functions, we can actually write code that understands other code. It's one of the foundational ideas of computer science, and it just opens up a universe of possibilities. Which kind of leaves you with a big question to chew on. If we can teach a computer the rules of its own language, what's the limit? Thanks for diving into this with me today.